Assalamu alaikum. Today I am going to discuss about IGCSE O-level physics. O-level physics, chapter 4, momentum. Momentum is a very basic chapter, a basic concept for any physics student. The learning objectives in this chapter. After finishing this chapter, we will learn about relation between momentum, mass and velocity. Momentum equal to mass into velocity. Momentum is denoted by P. P equal to m into v. After completing this chapter, student get idea about safety feature of a vehicle. How the safety feature of the vehicle is related with momentum. Then they will learn about conservation of momentum, how they can use momentum to calculate mass, velocity or momentum of an object. Then there is a important relation, force equal to change in momentum by time taken. So F equal to final momentum mv minus mu, that means change in momentum divided by time taken. Then student can understand the Newton's third law. That means every action has an equal and opposite reaction force. So every action force has an equal and opposite reaction force. So this one is the Newton's third law of motion. So now detail about this chapter. This chapter is for paper 2 only. So this is for chapter 2. It will come paper 2 only. So momentum basics, specification in Edexcel IGCSE O-level, specification point 1.25p. Know and use the relation between momentum, mass and velocity. We know momentum is the product of mass and velocity. Momentum is the product of mass and velocity. So here is the relation momentum equal to mass into velocity. Momentum is denoted by P, small letter P. P equals to m into v. Here m is the mass, v is the velocity. Momentum is defined by the equation momentum equals to mass into velocity. Remember, momentum is a vector quantity because it has both magnitude and direction. The direction of the momentum will be the direction of the velocity. Here velocity is a vector quantity, that's why momentum is a vector quantity. So remember this relation, P equal to mass into velocity. Then where P stands for the momentum. So here P is the momentum, M is the mass, and V is the velocity. Now, so here the mass of the object is M, small m, and velocity V. It moves right direction. So momentum equal to mass into velocity. Momentum is defined as the product of mass and velocity. The unit of momentum is, because the mass unit of momentum is mass and unit of velocity is meter per second. That's why unit of momentum is kg meter per second. Kg meter per second. Momentum is a vector quantity because it has direction as well as magnitude. This means that momentum can be negative as well as positive. Very important. Momentum can be negative as well as positive. Very important point. That means momentum is a vector quantity. That means momentum can be negative as well as positive. If the object traveling to the right has positive momentum, an object traveling in the opposite direction, that means to the left, will have the negative momentum. Now, safety feature of the car or any vehicle. Specification point 1.26p. Use the idea of momentum to explain safety features. Momentum is a way of measuring how difficult it is to stop a moving object. Very important thing. So momentum measures how amount force is required to stop something suddenly which was in motion. The greater the momentum of an object, the harder it is to stop it. So very important. So if the momentum of an object is greater, then it will be difficult or it will require more force to stop suddenly. Stopping an object suddenly requires a large force. In order to keep people safe, the force acting on the people need to be kept minimum to a minimum value. Very important. This can be achieved by bringing them to rest slowly. So there is a relation, force equal to change in momentum divided by time taken. So here, so if we want to reduce the amount of impact force or any force, then we have to decrease the change in momentum or increase the time taken. That's why stopping an object suddenly requires to a large force, and in order to because suddenly means very short time. If the time is very short, then force will be more. That's why stopping an object suddenly, that means instantly, requires a large force, because here time taken is very short. If the time taken is very short, then force will be more. In order to keep people safe, the force acting on people need to be kept to a minimum value. This can be achieved by bringing them to a rest slowly. That means if the time taken is more, then force will be less. So in order to keep people safe, the force acting on the people need to be kept to minimum value. This can be achieved by bringing them to a rest slowly. safety devices such as seat belts, car airbags achieve this by cautioning an impact causes a person momentum to change more slowly. That means we can reduce the amount of injury by reducing impact force. How we can reduce impact force? By increasing the time of collision by using seat belt, airbag. This safety feature increases the time of collision, time taken to stop something. So impact force will be reduced. Then injury as well as injury amount of injury will be reduced during car crashing or any car accident. Now next topic, conservation of momentum. Specification point 1.27p. Use the conservation of momentum to calculate mass, velocity or momentum of objects. In the absence of external forces such as friction, the total momentum of a system remains the same. This means that in a collision, the sum of momentums before collision will be the same as the sum of moments after the collision. That means in any type collision, in any type collision without any external force, total momentum before collision is equal to the total momentum after collision. Very important concept. That means in any type collision without any external force, total momentum, that means the sum of momentum before collision is equal to the sum of momentum after collision. Here there are two objects here. One is small m, mass of the object is small m. Here speed, it moves right direction with a initial velocity u, but the blue one, the mass of the blue one object is capital M, and it is at rest. That means initial velocity is 0. On the other hand, after collision, the smaller object, red one, moves left direction with a final velocity small v, and blue one whose mass is capital M, it moves right direction with a velocity capital V. Then total momentum before collision equal to small m into small u, because it is initial momentum. That means total momentum before collision. On the other hand, the momentum of the blue one, initial momentum of the blue one is 0. That's why the total momentum before collision equal to small m into small u. On the other hand, after collision, total momentum after collision, the blue one object with mass capital M, it moves right direction. That's why the momentum is positive, capital M into capital V. And red one moves left direction with a velocity small v, whose mass is small m. That's why momentum will be minus, negative, small m into v. So total momentum after collision will be capital M into capital V minus small m into small v. In the above diagram, the total momentum before and total momentum after must be equal. That's why small m into small u, that means total momentum before collision, is equal to the total momentum after collision. That means capital M into capital V minus small m into small v. So in this case, remember, notes that because the red ball is traveling to the left after the collision, its momentum will be negative. Hence the minus sign in the above equation. So remember this thing. This minus sign after collision comes because it moves left direction after collision. Then next, force, the relation among force, relation between force and momentum. Specification point 1.28p. Use the relation between force, change in momentum, and time taken. So we know force equal to change in momentum divided by time taken. So F equal to mv minus mu. mv is the final momentum and mu is the initial momentum. So mv minus mu is the change in momentum and t is the time taken. So when an unbalanced force acts on an object, the object will accelerate. This will cause its momentum to change. The change in momentum is related to the force by this equation. So force equal to change in momentum by time taken. So F equal to mv minus mu divided by t. Notice that if the time taken for an object changes, its momentum is small. So remember, if here mv minus mu, that means change in momentum is numerator and time taken is a denominator. So if a denominator is less, then force will be more. That means here time taken, if the time taken is more, then force will be less. On the other hand, if the time taken is more, then force will be less. That's why if the time taken for an object to change its momentum is small, very important. The time taken for an object to change its momentum is small, a big force must have. Very important. The time taken for an object to change its momentum. Time taken for an object to change its momentum is small. That means t is small. A big force must have acted on it. This can help us to understand the safety feature of any vehicle. In any collision or impact, force acting on a person or an object can be reduced by increasing the amount of time it takes for its momentum to change. there. So in any vehicle, there are some safety features like seat belt, airbag. This increases the time of collision between any car crash or accident. If the time taken or time of collision is more, then impact force will be less and the amount of injury of the passenger and driver will be less. So remember this thing. Next thing, Newton's third law of motion. Specification point 1.29p. Specification point 1.29p. Demonstrate an understanding of Newton's third law of motion. Newton's third law of motion states that when one object exerts a force on another object. So when one object exerts a force on another object, that second object will exert an equal force on the first object in the opposite direction. Very important. When object A, say it is a demonstration for Newton's third law. When an object A object A exerts a force on the object B, object B. So force FAB to the right direction. Then object B will exert an equal force on object A in the opposite direction. So FBA. That means B object gives a force to the A object to the left. So if A to B is equal to the F B to A, but there is a minus. Why this minus sign? Because minus sign indicates that force B to A acts to the left or opposite to the force given by A object to the B. These equal and opposite forces help us to understand why momentum is conserved. Each object will gain an equal amount of momentum because the forces are equal but in opposite direction. These two changes in momentum are equal and opposite. They cancel out. So each object will gain an equal momentum because of the forces are equal but in opposite direction. These two changes in momentum are equal and opposite. They cancel out. So sometimes we use this formula like, okay, say this one, the mass of m1, initial speed u1, and the mass of the second object m2 and initial speed u2. It moves right direction, also moves right direction with a initial plus p greater initial. That means here u1 is greater than u. They move in same direction in a linear way. So before collision, it is before collision. So here total momentum, the sum of momentum before collision, before collision M1 U1 plus M2 U2. Why plus? Because they move same direction. But after collision, the speed of the second object M2 increases V2, and speed of the first object increases and it becomes V1. Here V2 is greater than V1 now after collision. And after collision, then the sum of momentums after collision will be M1 V1, M2 V2. So according to the conservation law of momentum, total momentum before collision, here M1 U1 plus M2 U2 is equal to the total momentum after collision. That means sum of momentum after collision M1 V1 plus M2 V2.